And now, give it up for Kevlin Henney and the metaphors we code by. Thank you very much.
Dude, thanks. Good morning. How are you doing? Okay? Excellent, right. So, here we are. Middle of the week. And one of the things I enjoy about German so much is that sometimes there is nothing left to the imagination. And today's day name is middle of the week. Just so you know where you are. Truly centered. And what I want to talk about today is something that has fascinated me for years, and I've kind of danced around trying to understand the notion of metaphors and how they relate to the way that we think, the way that we name. I'm going to immediately offer you the disclaimer that I am not a psychologist, I am not a linguist, I'm just somebody who's kind of interested in this stuff. So there is clearly a lot more to this than I'm going to tell you, but it should be fun. Now, once upon a time I just used to put my Twitter handle up, but these days, well, Twitter we have an X relationship with a lot of the time. These days, there's been certain fragmentation in the social media space. So honestly, there it is, just find me, okay, if you're interested. Stalk me. My name is somewhat internet unique. In fact, even the first name, although half the time most things will try and correct it for you. I refuse the correction. And there's an interesting thing. That name, that combination was coined before there was the concept of an internet. And I'm going to come back to networks a little bit later. In terms of other things, Marco said at the weekend, elevator ride at the Marriott Hotel starts just like KanDDDinsky will, with an at Kevlin Henney. For various reasons, which I'm not going to go into in this talk, my name is associated with failure screens. And I have been asked, what's it like to have your name be associated with failure, Kevlin? I mean, there's an interesting thing that long after I'm gone, people will say, yeah, there was this guy, Kevlin Henney, and, he must have walked around and created a lot of failures. He was a software consultant. That's not the cause, but these are of interest. Now, looking back 5 years, let's go back 5 years. This is the opening slide to my talk at KanDDDinsky in 2018. This is the first content slide. So I thought, interesting enough, I will actually use exactly the same slide, same fonts and everything. I'm going to quote from Meyer Lehman, and I will quote from his same paper again a bit later. I think this is a classic paper. It's published in 1980. It's a culmination of a lot of his work in the 1970s. Very much as the title says, programs, life cycles, and laws of software evolution. He was very much ahead of the curve on this. We'll come back to that. But what I want to focus on here is the words. I think he enjoyed writing this. It's a lot of fun. Okay? I mean, this is it. Any program is a model of a model within a theory of a model of an abstraction of some portion of the world or of some universe of discourse. Oh, that's just fantastic. Sitting there in the middle of a very credible paper. And I offer you this. The next time somebody, probably in your circle of friends who are not software developers, or in your family, says, so what exactly is it that you do for a living? Give them this. They will not ask you to fix their computer. Okay? They'll kind of back away, nodding. Okay, thanks. But one of the key words here is model. In fact, model is used extensively. And it's kind of interesting because as I was thinking back, I thought, okay, so I came to Berlin 5 years ago, and I did a talk on meaning. And I was just thinking back, and I suddenly thought, model, there's a thing. I was reminded recently that there was a word that I coined in a master's degree I did many, many years ago, where I was talking about object systems and concurrency, in fact, the actor model. And I used this term. I thought, I'm going to sneak this word in and see if my master's degree supervisor notices that I've just invented a word. Modularity. Because what I wanted to do was communicate the idea that a communicating set of actors, communicating set of objects with their own state and messaging protocols, not only were they modular, not only did they have good modularity, but they had good modularity. And I actually ended up using and offering a more formal definition in a keynote that I did last century, a measure of the correspondence between the components of the problem being modeled and those in its solution. So, feel free to borrow this word because it is directly what we're doing here this week. It is that notion of correspondence and alignment. Now, of course, there's no such thing as a perfect model. But there is this idea of trying to bring things, as with any system, into some kind of alignment. It's probably an uneasy one. There's probably a little bit of movement. But at least attempting that, and the very process of doing so, is itself interesting. Now, as a general point, I'm very interested in words and definitions and meanings. I like dictionaries, for example. In fact, these are the only things I install on new laptops. I actually are from DVDs and CD-ROMs. There's only, 3 dictionaries: the Oxford English Dictionary, the Conceit, and the Merriam-Webster. And these days, people don't have optical drives attached to their computers. So my wife can always spot when I've got a new laptop because I'm running around the house trying to find the one optical drive that we have somewhere collecting dust, just so I can install the dictionaries locally. And I also have physical dictionaries. I think they're fascinating. Now, the thing about the Oxford English Dictionary is that if you are interested in looking up the meaning of the word, this is absolutely terrible. It's useless. That is not what the OED is for. This is a book of etymology and history. It doesn't show you usage, it shows you history. So the first definition is the oldest, which if you're absolutely into this, that's fantastic. If you want to know what they meant in the 16th century by the word you're currently looking up, this is great. Otherwise, it's absolutely terrible. Fortunately, this is absolutely where I'm interested. So we're going to talk about metaphor. And we are offered this idea of metaphor, this definition, the figure of speech in which a name or descriptive term is transferred to some object different from, but analogous to, that which it is properly applicable. And if we look at the actual origin, metaphora, it's Greek, ancient Greek. It means literally to transfer. That is the whole idea of a metaphor. It is the idea, if we're going to explain this in terms of this, it's going to help you understand. It's a mapping. Now, this is kind of cute, it's kind of mathematical, sort of, but there's something deeper here. When people learn about metaphor, when they think about metaphor, often their mind is cast back to school, where they may have studied some poetry or some plays or something like that, and that in class they were asked to explore the metaphors and the metaphorical language, which is very tough for some people. And I noticed this with my younger son. He really struggled to get poetry. We weren't surprised because he's on the spectrum. But the whole idea of metaphor is incredibly challenging if somebody kind of brings it out like that. But there is another aspect here, is that it's not just a thing that belongs in poetry and flowery language. The idea is that metaphor actually is deeply woven within the very way that we think. It tells us how we use our prepositions. Okay? And you notice this when you switch from one language to another, why in one language something may be at something, but in another language it may be by something. Okay? And these are all the little bits and pieces that you're kind of going, well, hang on, why is that so illogical, you say, when you learn another language? Why is that at and not by like it is in my language, my first language? And it's just like, yeah, there's no logic to it at all. Or rather, there is. And it comes from this. So there's been a lot more work since this book, but this is kind of very much a landmark book. It was published in 1980. Funnily enough, the same year as that Meyer Lehman paper. George Lakoff and Mark Johnson, and they observed in Metaphors We Live By, metaphor is pervasive in everyday life, not just in language, but in thought and action. They go on to say that in trying to describe metaphor, it informs everything about the way that we reason, particularly with abstract things. They give a number of examples. I can't remember if it's in the book or in something else, but there's a very interesting point we talk about in terms of we relate something abstract typically in terms of something physical. And a lot of the things we relate to physically are ourselves. So you might say, maybe you're showing somebody pictures of your holiday. and you've been on holiday, you went to the mountains, and you say, oh yeah, here's a picture of me in front of the mountain. Okay, I have some news for you. Mountains don't have fronts. That's not a thing. Humans have fronts, okay? But it's in front of the mountain. It's like, yeah, it doesn't make sense. A mountain does not have such symmetry or breaking of symmetry. But we're quite happy to use phrases like that. We use them in relation often to our physical selves. And they point out this idea, the essence of metaphor is understanding, experiencing one kind of thing in terms of another. And they offer a number of examples. And what we see is that with many of these create a system. They create a system of meaning. And that's, so, we're going way beyond the idea here of just like finding nice names for things or understanding just one thing in terms of another. We're creating a system of meaning with entailments. So time is money is a very common one in the West. And certainly in English there, it informs a number of phrases. Without even thinking about it, I mean, how are you going to spend today? Spend is the language of money, okay? Is it worth spending my time at this keynote? Well, yeah, it is for me, because I've been asked to say, but you can sleep if you want. But the point there is that informs all of the little words. It's not just about the idea of time is money in the most obvious sense. It's the subtle sense as well. We see this idea when talking about other abstract concepts. So time is clearly very abstract. Argument is war. Okay, what does that do for us? How does that inform our language? She attacked his argument. Attack is the language of war. He was defeated. Okay, it informs that kind of language. But we can also have multiple systems. Arguments as buildings. His argument was based on a solid foundation. Arguments don't have foundations, that's buildings, okay? But clearly, once you've got that, you can have the idea of that perhaps his argument was not built on such a solid foundation, and it collapsed, okay? And we see, oh yeah, buildings collapse, yeah? And one that is kind of an interesting one, again, linguistic and cultural, happy is up, sad is down. To the point that people will sometimes say, how are you feeling? Upbeat. I'm feeling up. There's even, there's the feel-good site called Upworthy. Up is a direction that we have an association with. Feeling down. Okay? And there is that notion, and when we talk about the notion of, say, words like depressed, that is a down thing. Okay? Literally, that's what the word means. And love is a journey. Where is this relationship going? Relationships don't go anywhere. They're not a thing that goes. But how do we talk about them? They're such an abstract idea. So we have all of these systems. That's great. So we've understood that we think in these terms. But let's talk about what happens when we take this to Let's take this to the computer. Now, there is an interest. So this book was published 2008, Pragmatic Thinking and Learning, by Andy Hunt, one of the pragmatic programmers. Unfortunately, in the subtitle, this is the funny thing, is sometimes we will use terminology in the software world and then try and bring it back to the real world, and we end up with refactoring your wetware. Refactoring is to change something so that it has no observable effect on the outside. That's not what this book is about. It actually wants to have an effect. Sometimes people get a little bit excited and use the word refactoring to just mean changing stuff. That's not what it means. Yeah? It's not just changing stuff. But there's some nice observations in here, many of which parallel some of the stuff I've done myself. But Windows is one of my favorite examples. What we call windows on the computer screen aren't really windows at all. But they give us a language and a model through which we can understand things. Okay? Windows, that gives us a concept of a view. It gives us the language of opening and closing. But of course, there's not a perfect match. I mean, I don't know if you've ever tried to resize a window. My wife and I have done in 2 houses. It's very expensive. And minimizing windows, I mean, they could have gone the whole distance and said, yep, we're going to draw the curtains on this window. And it's just like, no, that starts getting silly. So what we do is we understand that a metaphor is not the thing itself. It's not going to be a perfect mapping. And it turns out we're also quite happy to mix our metaphors, probably more so than we would acknowledge. I mean, windows are part of the desktop metaphor. Do you keep windows on your desktop? I mean, that's kind of weird. So I can see a window when I'm at home. I can see a window from my desktop. It's got great resolution. It shows me my garden. Sometimes the colors are a bit dim, but that's just from living in the UK. But we have this idea, it creates a way of thinking about something. But that's very different. We don't use, for example, the language of process. What is the language of process or the language of machines? The language of machines, it's actually now the most common the word with the most meanings in the Oxford English Dictionary. Run. Okay? Run is the language of engines. It's the language of machinery. You run an engine. So we don't use the language of starting and stopping and running when it comes to a window. We talk about opening and closing. Even though technically, if you actually look at what's going on underneath, it's obviously the same. So we have that. And a folder on your hard disk isn't a real folder. Yeah, we have these ideas. We have folders. They contain files. What can you do with a file? You can open it, you can close it, you can read from it, you can write to it. But now we've got to the point where so many of these are concrete that, with my kids, it's a case of like showing them, this is a real file. What, the actual? Yeah, this is a real file. We've reached that point where the language takes over. But there's another interesting thing here. The metaphorical language captures a point in time. Sometimes there is an implied time step. So what machine does Andy use? He's a Mac user. He uses a trash can. I'm not a Mac user. I'm a Windows user. I have a recycle bin. Now, why did Windows choose recycle bin and not trash can? I mean, given that, if those of you who use C# will know that Microsoft has no problem just ripping off a whole look and feel of a language. So they don't just do it to be gratuitously different. They do it because of the time. Because in the 1980s, when the trash can metaphor became something with Apple, recycling wasn't a thing. It's a reflect in the mid-1990s, recycling, we had logos for it. In the mid-1980s, there were no logos for recycle, or the concept of recycle bin did not have a meaning. It's actually a more accurate metaphor. Okay, so the point is that the Macs are stuck with the 1980s view of how to dispose of things, whereas the Windows view started at a different point. It captures a different point in time. We see this in terms of other language that we might use, like sprint. Okay, the purpose of sprint. Why do we call these damn things sprints? They're iterations. We don't do them because they're fast, although I have heard of teams saying, yep, we're switching from iterations to sprints. Why? They sound faster. The whole idea of sprint is that back in the early 1990s, the term iteration implied something much longer. It wasn't anchored to that meaning of 3 months. But if you said we're doing iterative development to somebody in the early 90s, you were probably talking about 3 to 6 month iterations. If you were on a 4-year project, and you were doing iterative development, you might have as many as 8 iterations. The whole idea of sprint was something shorter. That was the implication. And without interruption. That was another implication. It's in a straight line. It's direct. These days, we've lost that, so now people are just exhausted through micromanagement. So we have the idea that some of our terminology captures different points in time, not just the meaning that we thought it did. When you write concurrent programs using threads, you're not sewing. No, you're just wrapping yourself up in a world of pain, a cocoon of angst and fear and bugs, but that's a different story. It's just a metaphor. So we've got this idea here, and we use it everywhere. I mean, even the word computer. You go back far enough, a computer was a person. In fact, there was an interesting crossover point. This is in the 1940s. That's one of the Colossus machines used to break the Lorentz cipher. And here you see 2 computers with a computer. But that thing would have been distinguished. Oh, by the way, whenever people talk about old computers, they always like to joke about how much memory these things have. And like how many bytes. This had 0 bytes memory. It was not a stored computer. It's a stored program computer. But it did stuff. It had valves and tubes and knobs and was an automatic computer. By default, you said computer would refer to a person who did calculation. And then it kind of all switched over. We use other metaphors as well. Memory. How much memory does your machine have? Yeah? But the funny thing is, we have somehow detached that and absolutely forgotten that it's a metaphor. I mean, we don't talk about, this is how we think of memory. We think of memory in a very physical sense. We talk about its quantities, but we don't talk about forgetting. Okay, we don't talk when we talk about computer memory. We don't say, "Oh yes, I need this to be remembered, and I need this to be forgotten." We mix our metaphors. Going back to trash cans, we have garbage collection and stuff like that. That has nothing to do with memory. Although there are days where I feel that maybe it does. Sometimes the metaphor transcends to the point it doesn't have any associated entailment and vocabulary, and we even forget that that's a thing. So, a number of years ago, I co-authored this book, Patent-Oriented Software Architecture, Volume 5, and there was an observation I made in one of the chapters. A physical and invisible domain of software is more about metaphor than matter. That we end up, and then based on personal experience, if you think about it, look through a piece of code, and you will find that pretty much every name is metaphorical. Not every name. There are some names that are actually just names that we have invented for this particular space. Sometimes we use terminology. We create terminology to describe something. Sometimes it's an acronym, so SOAP, REST, all of that kind of stuff. These are invented words. Okay, they are invented for a purpose. Sometimes we invent words to describe our practices, and they are not metaphorical. DevOps is clearly, for example, a coined word. Sometimes it's just a simple description, continuous integration. We talk about CI/CD pipeline. Pipeline. Now we're getting somewhere. That's a metaphor. But a lot of our vocabulary is metaphorical, but not all of it. There's some bits that are actually just constructed phrases that are accurate descriptions or other coinages. So, as I said, this is something that's been of interest for a while. I run a few workshops with my friend Andy Longshaw. This was one at the European Patent Languages Conference back in 2006. And Andy and I did a write-up of that metaphor in software development. We ran a similar workshop the following year at the SPA conference, 2007. You can see kind of foreshadowing of the title of this talk. Trying to explore what metaphors people used, but also how well metaphors stood up, which metaphors were the most effective, and also which communities were really bad at it. We all came to the conclusion, in fact, independently in both of the conferences, that security people suck at metaphor. Yeah, about the only one they've ever got right is virus when we talk about security. But the whole idea of a demilitarized zone, that doesn't work. A demilitarized zone is not a thing that the company owns. It's normally jointly owned. It's you don't have the control over it that a DMZ does in the real world. It's not implied there. Similarly, you have other things like firewall. We have firewalls on our computer, but the purpose of a firewall in a building is not to keep the bad stuff out. It's to keep the bad stuff in. Yeah, it's complete inversion. The idea of firewalls in buildings is to stop the problem spreading throughout the building. If there's a fire, you want it contained in this space here. A firewall on a computer, therefore, should say, "Okay, I've found a virus, and we are going to just unhook you from all networks. We're going to air gap this computer automatically." That's not what happens. A firewall is a defensive mechanism against the outside world. It's a complete inversion. They got it back to front. So we had a good fun taking the piss out of security people. Apologies if you're a security person. They're still getting it wrong 15 years later. But I said we'd see this tree again. I don't just use it as my backdrop. I mean, I like this picture. I take a lot of photographs, so the copyright on all the images is mine. It simplifies intellectual property. It's a tree. Well, it's a bunch of trees, but let's focus on that tree there. Why are we talking about trees? Well, Donald Knuth made this observation. Trees sprout up just about everywhere in computer science. talk about this word up. They don't sprout up everywhere in computer science. They sprout down. I remember telling my kids a few years back, I said, oh, yeah, we have trees. I was showing them something on the computer, and I said, that's the root. But, trees, we have them all over software, but they're upside down. And my kids are looking at me going like, this is one of those things where you're pulling our leg and just kidding us around, Dad. No, this one's real. Not like the other jokes I tell you. This is actually the real thing. It's just like, how could a whole discipline screw this one up so badly? Maybe we should have just called them Australian trees. I don't know. But here, this relates to a wonderful observation from Tony Hoare. You cannot teach beginners top-down programming because they don't know which end is up. Honestly, I don't think that's just isolated to beginners, okay? But we do other things as well. I've shown you a black and white image there, but obviously we know when we think about things, when we think about trees, we have a color association, and most strongly, except for autumn perhaps, we tend to think of them as green. Do we do this in software? Well, no, we don't. Or yes, we do. We do have color, but we have red-black trees, which is a completely, had we been thinking clearly on this one, they would have been something, I don't know, like green-red trees or something. But actually, I'm colorblind, so that wouldn't have helped. But the idea of, if we're going to use color, why don't we use colors that are more natural to trees? And maybe perhaps red-black trees would instead be green and kind of like sepia-tinted trees. That would have been quite a nice name. But the point there is that when we do get around to use color, we don't use it in the way that's expected of the original space. And obviously, every talk has to have an XKCD reference. And of course, your parents won't invite you back if you start using that Meyer Lehman quote that I gave you earlier. This is a good way to isolate yourself from family. Now, I did this piece for O'Reilly Radar a couple of years back on exactitude and technical depth, where I spent a bit more time talking about metaphor. And the observation that we need to always respect, it will never map its target perfectly. A metaphor is a conceit, not an identity. Because if it were exactly the same, then it wouldn't be a metaphor. That's the whole point. So sometimes people say, oh yeah, that metaphor is not right. That's probably a subjective thing. They're not, unless you're being very pedantic, that's not actually an accurate way of describing a metaphor. Metaphors aren't about being exactly right. Somebody says, oh, that metaphor is wrong. That's a very judgmental word. I don't think many metaphors are actually wrong. I think some of them really don't fit very well, but they're not necessarily wrong. It's not Boolean right and wrong. That is a question of identity. But we do use this stuff. We do actually respect the intent. We might have got the, we might not respect the color or the orientation, but we use this language. And we can see it everywhere. In fact, actually, at the speaker's dinner last night, there was some discussion of trunk-based development, and we talked about branches. Nobody sat there worrying about the metaphor. Everybody knows what you mean. Although if you are totally focused on trunk-based development, maybe trees are completely the wrong metaphor to start with, might I suggest, because the whole idea of a tree is that it has branches. It's if you're doing trunk, if you're fully committed, literally, to trunk-based development, then you should be talking about, no, this is a denuded forest. It's like it's a wasteland. There's only kind of trunks here. It's like, it's not a good scene. But nonetheless, we use this language. We use it all over the place. We might say, oh yeah, here's an object structure, and the leaf nodes. We don't even question that. So the language informs us. I mean, imagine having to come up with words for this stuff if you didn't already have a system of meaning that was available to you. And there's an important point here, is that a lot of these things come with this metaphorical entailment. If you like, it's an association cloud, a tag cloud of possibilities. As they describe, as Lakoff and Johnson describe, metaphorical entailments can characterize a coherent system of metaphorical concepts and a corresponding coherent system of metaphorical expressions for these concepts. So what we're after when we are looking at naming is not just, and this is something that many years that I talk, whenever I talk to developers, whenever I'm running workshops or doing consultancy or just having a chat about code, trying to emphasize the idea naming is not merely better labeling. Okay, it's not about labeling. I'm not just trying to label something. I'm trying to take an idea and put it in your head. It's really hard. What we're trying to do is put ideas in each other's heads. And we're not just trying to put a word, we're trying to put a system of meaning or the suggestion of a system of meaning. Here, take this, and hopefully some of the other stuff goes with it as well. We're doing this by suggestion, as opposed to direct communication. This is this idea, this is this idea. What we're doing is we're saying, here is this idea, and with it comes a lot of other things that I don't have to introduce, or that you can deduce for yourself once we participate in the same system of meaning. Now, I hope you've already had breakfast, otherwise this picture is going to make you hungry. So what am I talking about here? We're talking about pancakes. No, we're talking about stacks. Of course we're talking about stacks. Why wouldn't you talk about stacks? The most overspecified data structure in the history of computer science. And yet, you'd think we'd be able to name this stuff right. You know, I mean, it's 2023. Anybody know when the first stack example appeared? I'm going to guess it was the 1960s. I have read papers of the early 1970s I can definitely cite that use stacks, but I'm going to guess 1960s. So let's talk about these things. What do they have? Well, stacks have a size. Okay, so size is not a bad name. Okay? They can have a count. That's also, yeah, number of pancakes. Yeah, that might work out. So that's a discrete concept. It's countable. Okay, that works. What about length? No, that's just stupid. Length is a horizontal concept. Stacks are a vertical concept. Still freaks me out. Anybody work with Python? Yeah? Actually, a couple of you. Right. If you want any size concept, it's called length. Well, actually called len, because apparently there's a little bit of a kind of shortage of letters going around. But we call it len. We end up with stuff like that. So, but this is the interesting thing, is that there's a concept of there's an orientation. Just like happy is up, sad is down. Length is not up or down, it's horizontal. If you want up and down, then height or depth. Yeah? But the important thing, height is here's the base, and depth is here's the base. We do it the other way. And that gives us, however, once we've understood that it's a vertical orientation, the whole concept is a spatial and vector-based concept, then it has a top. So that's the natural name for the top element. Yet somehow, APIs everywhere screw this one up. I mean, there are a few that get it right, but we've had this crazy idea. I think I first really noticed it in the Java API. C++ got it right by calling it top. Java said peak. What the fuck? Oh, it's like you're having a look. I can see it's on the top. There's no having a look. I don't need to have a look. It's right there. That's the whole point of a push-down stack. Quite literally, that is the point. The top element. It's not the peak element. That would be this. Hang on, wait a minute. Next word, peak. That's a different spelling of peak for those of you who are still struggling with the craziness that is English spelling. That's a different peak. I mean, that's kind of cute. There's a little bit of me that wants to call it that because it's like the peak of a mountain, going back to mountains. They don't have fronts, but they do have peaks. No, that's really bad because it's too clever. It's just not where it is. And then you have this kind of fetish for putting the word get in front of everything. Can I just remind you that get in English, and this is also for the first language English speakers as well, they forget as well. Get in English means modify the state of. It does not mean I'm asking you a question. It means please have a side effect on this object. Okay, so if I go to a cash machine, if I go to a Geldautomat, which I have to in Germany because you guys have not yet gone fully cashless. It's quite bizarre coming to Germany. It's just like, oh, I need cash again. Shit. So I have to go and get money from a machine. And you know what? That has a side effect on the machine, on my wallet, and on my bank account. That's a huge side effect. If you get married, that has a big side effect on your marital status and other aspects of your life. Okay, so the point is get means change the state of, just in case you want to have that debate at some point at work. So what does get top mean? Get top is a movement. It's not a value, it's not a thing, it's not that. Get top means, well, we don't call it that. We call it pop. And they are called push down stacks because the other one is push. That's where the whole idea comes from. So there's a system of language, and you'd think that we understood it, but because it's right there and we don't pay attention. This is the important thing when we come to understanding systems of meaning. Remember, when we talk about domains, there are many domains, and one of them is the infrastructural stuff that we build. And we are often responsible for naming this stuff. And therefore, the domain comes from within technology, and it comes from within us and our decisions. We're not necessarily going to talk to somebody to really discuss this in terms of somebody else who might not be a software developer. This is our own space. And sometimes we're not very good at it. I mean, this gives rise to Phil Carton's classic observation. There are only two hard things in computer science: cache invalidation and naming things. So if you struggle to name things, what should you be doing? Well, here's some of my dictionaries and some of the books that I have on words. You know, I know people who make an actual point of like, yeah, let's get a dictionary. Let's have a team discussion around this, okay? So other ways of dealing with these problems, a wonderful suggestion I think I got from Barney Della a few years back, is that whenever they're kind of like team or ensemble programming, whenever his team coding, they can't come up with a name for something, they use a keyboard smash. And eventually, people get tired of referring to, and eventually you start hearing people actually draws out the vocabulary. Yeah, but working with a dictionary. So what I love is that a dictionary is ultimately self-referential because it contains the definition of itself. Yeah, so it's a book that lists the words of a language in alphabetical order and gives them meaning or the equivalent in a different language. Obviously, when it comes to software, we're not really worried about the second part. But I'm just going to tell you, there's one idea here. One idea. A dictionary has a well-defined ordering. Let's go to the .NET library. Let's iterate through a dictionary. The order in which the items are returned is undefined. What? One job, people. One job. There is only one thing that dictionary means. And actually, I know who we can blame this for: Smalltalk. Because a lot of people go, oh, Smalltalk, it's so beautiful, it's so pure, and all the rest of it. Yes, but it totally ballsed up some really basic points about how to name stuff. So the point is, the idea of a dictionary that is unordered, that's not useful. That really is not useful. Just you pause for a moment and go, yeah, we could have done this one differently. There's lots of alternative names. So if we're looking at systems of meaning, let's try something else. Let's just see where this one takes us and explore this idea of different idioms and different entailments. Okay, that's a source. That's a sink. What's the thing in the middle? All right, did you say space-time decoupling? Well done. Because that's what it is, isn't it? That's the actual description. Think about it. Pause for a moment, and that is the most accurate description of what it is. It's not a metaphor. It really is what it is. It's a space-time decoupling. What do you use cues for? Just think about every single cue that you've got. It's either related to space or time decoupling or both. Oh, yeah. Yeah, I never thought about it like that. That's provocative as a way of thinking. It's just your colleagues probably won't thank you for this. Okay, yeah. But if I use the term source and sink, then it's natural that I would call this a pipe. But if I shift the vocabulary, that doesn't feel quite right, so we'll shift that one again to that. So notice there's kind of like these little kind of systems and implications. And what's interesting is that in the real world, a queue being a horizontal concept, a queue is a thing that people do. And different cultures have different ways of queuing, depending on the country that you're in. It's been often described that the English can form an orderly queue of one, whereas there are some countries where there is no queuing discipline whatsoever, and it's more like a heap. There are lots of different ways of describing this. But what is interesting, just look at the two words on the outside, producer and consumer. That's a different metaphor. Because if I'm in a queue in a shop, then I am a consumer. I'm in the queue. The consumers are in the queue. Yeah? So what we've got is actually we've got two different metaphors that have kind of become so familiar that they've formed a system of vocabulary that is based on a collided metaphor. talk about capacity. And we can have various capacities. We can talk about things being buffered. We can have buffers to do with trains. Bounded. Tied up, okay? Contained. Asynchronous, okay? That's not really a metaphor. That is an actual description. That's a technical term. But the other two are metaphorical. What is interesting is that when we start messing about with things, we end up discovering a few things. First of all, if you have an unbounded thing, that's a really bad idea for a queue, just generally. Just don't have, except in prototype code, don't have unbounded queues. It's a bad idea. But what if we play with some of the other numbers? If you're going to have infinity, you've got to discuss 1. Yeah? What is a queue of 1? Well, we don't call it a queue of 1. We use other terminology. For example, this side of the relationship is often referred to as a future. The other side is a promise. But you can build a one-time future promise pairing using a one-place queue. We just don't talk about it like that. We use a different kind of idea and vocabulary set. We can even take capacity down to 0, because of course there are only three numbers, 0, 1, and infinity. Or actually, no. In computing, we're very worried about the word infinity. So we just say many. You know, many. We just we don't look at infinity. Yeah, it's like the abyss. It's just, you know, there's more, there's stuff, potentially infinite. 0, 1, what does it mean to have a capacity of 0? Well, it's unbuffered, it's synchronous. Actually, the term that we've ended up using for that from Tony Hall's CSP is, that's a channel. A 0-place pipe or queue is by default a channel. You get the same kind of concept if you're working in Go, by default. But you can actually make those buffered, in which case they cease to be what was historically known as a channel. The idea of a channel historically was a synchronization point, a rendezvous point. So there's an exploration there. How do we talk about these other things? What are the actions that we use? Add and remove, that's kind of very general collection-y type language. That doesn't feel, it's not wrong, but it kind of doesn't have quite the right suggestion. The fact that I've got arrows on my drawing suggests I want something that implies flow. Push and pop, I can borrow from stacks, but that feels a bit weird, although I do see some queues being push and pop. This one describes the control flow. That's not bad. I push onto it, I pull from it. That kind of, you know, and we see that language as well when we talk about pull-driven systems and so on. Push notifications and all the rest of it. So there is an implied notion of flow. Notice what I'm doing here is I'm exploring the language of flow, of movement. There's a suggestion there. I often end up with these because it's so neutral. In other words, sometimes you just say, you know what, I'm just going to use these because they are obviously to do with queues, and it stops me worrying about all the other entailments that might not be appropriate. So maybe that gives us following Java, and you know, we can talk about that. We can sort of see that there's a length idea, there's a capacity, it's horizontal. But there's more to this as well, if we want to understand this as a system. So this is a book I edited a few years ago, 97 Things Every Programmer Should Know. It's actually an open source book. You can find various versions online. Every now and then somebody emails me and says, hey, Kevlin, did you know somebody has pirated this book? And it's just like, no, it's perfectly fine. There are lots of Gitbook versions out there. I intentionally made sure the license was available for that. A lovely piece by Nicholas Nielsen, Thinking in States. In most real-world situations, people's relaxed attitude to state is not an issue. And people do have a relaxed attitude to state. And we find it, however, in technology as well. Unfortunately, however, many programs are quite vague about state too, and that is a problem. I find this in so many cases. Like a company I visited, I did some consultancy at, almost every visit that I ever did with them involved me at one point saying, let's just draw up a state diagram. Because everybody was focusing on the code and the names and the structure that they could see. And if they drew any kind of diagram, it would be either some kind of deployment diagram or some kind of class diagram with a suggestion of object instances. But nobody ever actually said, what are the states? What's the life cycle of this thing? And in doing that, I found so many problems or clarified so many things. One particular company, there was a disagreement in the room. We had about 6 or 7 people in the room, including the project manager. And we were talking about the development of a client-side app that could work in a connected and disconnected state. Okay? And therefore, when you reconnected it, there should be replication of state. And we seemed to be going round in circles, trying to describe what was going to happen. And I suddenly thought, I'm not entirely sure we're using the same words. Or rather, I'm entirely sure we are using the same words. I'm not entirely sure we're using the same meanings. So I went and drew up a state model. And the project manager said, that's not what I was thinking. So I then drew up his state model. Everybody else pretty much in the room go, okay, now I see what we're doing. Okay, so now we have a choice between, now we've changed the discussion. A choice between, this is now a design decision discussion. Except for there was one guy in the back of the room who said, actually, I wasn't thinking it was either of these two. It's amazing just drawing something can bring this out. But we find this in many cases. I find so many bugs in the real world when doing this. One of my favorite ones was a hotel in Istanbul. I was doing something for a company, and I went there, and it had one of these sort of two lights outside the room. One light said, please, stay away, I'm sleeping. The other light said, please come in and clean my room. And therefore, you can look at this and go, each light can be on or off. And there's buttons on the inside. Now, think about it for a moment. You're going like, yeah, that's cool. Except there's one state that should not be allowed. There are 4 states that are implied, but one state should not really be allowed. Come on in, I'm sleeping. That's not right. That should not be allowed. And guess what? It was. So now every time I'm in a hotel room that's like that, just check it. About 50% of them get this right and recognize there's an illegal state transition, and you're not allowed to do that. I also do it with lifts. I found a number of bugs in lifts and in cars. And it's really funny when you're in a lift or a car driving and you say, hey, there's a bug in the car's engine management code, and you're with somebody and you demonstrate it. They look really worried. There was one in a lift a few years ago. This was in Bangalore, and I remember spotting it, and on the way to breakfast, I worked out what the situation of the bug was. And I said, right, yes, you end up with there's a reset at this particular point, so therefore it always goes to ground, and therefore you have to go up again. And, so ended up 5 years later in the same hotel. And I was with a couple of other people, a couple of other developers, and I said, hey, there's a bug in this lift, you'll check this one out. And both of them are kind of like, what? And I was able to reproduce the bug. Mostly it's to do with what is the state of the system. So we can actually see and start visualizing this stuff and understand the richness of this system of words. We have the notion of data flow. We have the notion of control flow. NQ and DQ have a different flow to the data flow, which is left to right. But we also have the ideas of capacity and length, and we can visualize that easily. We can go further and actually draw up a state diagram, should we wish, to sketch it out. Because most of the languages that we use are not very good at state. State is not a first-class concept. I'm not talking about stuff that's held in fields. I mean kind of a macro state of behavior. But actually, if we're going to do it properly, then we realize there's a much richer version. And therefore, we have to start constructing certain words ourselves. Because it feels a bit picky, but the problem is that there are these other states. There is empty and non-empty. And that's not a convenient word. Is that, I have a non-empty glass. That's kind of a bit clunky in terms of English. But then we also then introduce non-full as a distinction. I mean, strictly speaking, non-full up here is non-empty and non-full, but we have to draw a line somewhere. But here we are constructing from an idea. And some of the language we're using is constructed and goes beyond the metaphor. But we also achieve really good alignment. You can actually map that structure directly through to some tests. And the tests have exactly the same nesting structure as the transitions and the states and the other diagram. And that's how to really think about this. What we've actually achieved here by understanding and using our own vocabulary and messing about with the choices of words, trying to describe, okay, what language are we going to use? A non-empty queue that is full ignores further enqueued values. I've chosen to use enqueued there. I could have chosen reject, but that felt a little bit strong. So I'm going to go for the idea of ignoring because it's perfectly fine and it's not an exceptional condition. So therefore, the language that we then use suggests certain things. If I use the term reject, I'm expecting an exception. Or I'm programming in Python. Just for those of you who don't program in Python, Python just says, exception. Pretty much for everything, even ending loops. You end loops by the underlying mechanism in Python is it raises an exception, which is why you should never get a Python programmer to help you park your car. Yep, back up. Yeah, you're good. You can stop now. Yeah, they wait till something bad has happened, and then they tell you to stop. So there is a whole idea here that we've got, effectively, we've achieved good modularity. But that idea obviously starts with the idea it's not just about the names. We've gone a lot further, and we've also applied it to our own systems. If you've not come across commit strip, absolute hoot, this commit strip. Data, too generic. Anybody got a variable called data in their code? Yeah. Apparently, so Peter Hilton did a kind of a search of GitHub a few years back to find out what the most common variable name, longer than one letter, because obviously it'd be I, longer than one letter was, and data was the most popular. Second most popular was data 2. The sequel, yeah. DataDB, unclear. Let's say list complete already used. Array list, data completed that? Nah. We must choose now or the client might cancel the project. Well, array list completed form without duplicate, too long. Yeah, unable to name variable, they go bust. Yeah, not yet happened to the best of my knowledge, but we do. I don't think you can spend too much time on this, or rather to recognize that what you're doing is you're not just trying to find a good name, you're trying to find a good system. You're trying to find something that fits together. And sometimes you have to step outside the names that you have to make it work. And you end up, as I've already implied, there are these systems where we end up with a collision. One of the focus group discoveries was there was a general consensus in the focus group that metaphors can be highly expressive, but to actively seek them might be too forced or the result too contrived. Okay, we're going to have a metaphor meeting this morning. We must find the right metaphor for the system. Now, that sounds kind of like a bit of a joke, but actually, it kind of happened a bit with XP. Extreme programming, there was one of the original 12 principles, or 12 practices, right there in the midst of all these other things, was metaphor. And it was quite interesting because this was something that, at the time, teams trying to adopt XP, and it's interesting just to say that in the second version of XP, the New Testament book, metaphor was dropped. Not because metaphor's not valued, but you can't consider it a first-class concept as we must have it. The idea of the system metaphor will replace architecture. That was kind of Kent's kind of focus. It replaced that. Now, the problem is architecture is already itself a metaphor. There's lots of different ways of describing that. But to say we're going to have a system metaphor, a unifying metaphor for the whole system, is problematic. Because first of all, you're assuming there is one. Metaphors just don't work like that. That's not how we think. We've already seen that in even the most trivial cases, we mash them together and are quite happy with the result, and we get by. But we also have, there's another aspect here, is one of the things that they discovered is that people start trying to have upfront meetings about what system metaphor are we going to choose, right at the beginning, before we've even built it. In many cases, a metaphor will emerge. If you hard code a metaphor and all of the implications, and therefore the structure in place right from the start before you know what you're doing, you've actually squeezed the life out of the very process that you're trying to encourage. So it ends up being dropped. Now, there's an interesting point that I want to come back to on DDD, because there's an interesting thing, a quote that I've used a number of times, and I've seen a number of other people use when talking about this question of alignment. There's a number of different ways of reading this. Domain experts should object to terms or structures that are awkward or inadequate to convey domain understanding. Developers should watch for ambiguity or inconsistency that will trip up design. Notice, many people will assume that this is all about discovery, and that is part of it. Trying to understand a system of meaning is partly about discovery, but it's not just about discovery. If you actually look at this carefully, you can actually see that there's an implication that not everything is just out there. There's not only discovery, there is actually creation. A lot of the time, we're actually creating the things. Sometimes, if you're talking to a client, they don't have a word for something that is incredibly ordinary to them. Because it's so incredibly ordinary, why would you even bother talking about it? Yeah? It's just something that they don't notice. Or a distinction that does not matter to them. Or that is context, not bounded context relation, but context-specific, sentence-level specific. They don't make a distinction. Or a distinction emerges from the legacy, but is actually not a helpful one to think about. And they're offering an alternative term might not contradict them, but it might help to clarify. It's not just the concepts that are out there. It's actually reflecting back. It's an active conversation. You're reflecting back, and you're not just giving them back the same words. You're giving them back a new system of understanding as well. So there is a lot of creation here. And so therefore, caring about metaphor is what allows us to sometimes bridge these gaps, to find the new words, or to stitch our different systems together. Obviously, we do this together, and therefore there's the term network. But let's talk about another thing, because I want to talk about, I said right at the beginning of the talk, my own personal interest goes back a long way. I was, you're assuming I have eyesight, but I know what the time is. And it occurred to me this morning, slightly depressingly, this was 30 years ago. I was working on a code base, and this is where I had the epiphany, oh crap, it's all metaphor. It's turtles all the way down. No, it's not. Turtles are a metaphor as well. It's all metaphor. And I was working on a code base, and C++ code, wrapping C code. We were using the word network. In fact, I like the fact that socket is itself obviously a metaphor. We were using a network, but we had a number of different networks in the code. There was the network here, and if I go to the OED, it says, yep, network, a system of interconnected computers. That meaning came to us in the early 1960s. That's when that started being used. So network in that context started being used in the early 1960s. So we had network, meaning TCP/IP network. And of course, that leads to the notion of distributed systems, and I guess then we start moving to a slightly different space with entailment when we talk about distribution. We use different language, and we defined it in POSA 4. Distributed system is a computing system in which a number of components operate by communicating over a network. Okay, so that's we kind of raise the idea of we say network is this level, distributed system is at this level. We make a distinction between network and distributed system. However, Leslie Lamport's definition is always the best one. A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. And so my publisher had this one a couple of years back. Fire in California, can't read your ebook in Pennsylvania. So we have all of this kind of stuff. But there's another term, network, that was used in our code. Funnily enough, this also dates back to the early 1960s. And this comes from maths. Yes, I am British, so it's maths, not math. You get more for your money. A graph, especially a digraph, in which each edge has associated with it non-negative number. Now, it turns out the 1960s were people really got into this whole graph and network stuff. There's diagrams like this. This is a network that features in this book by Christopher Alexander from 1964, Notes on the Synthesis of Form. Christopher Alexander is the guy who basically came up with patterns. That's a 1970s thing. But in the 60s, everybody was obsessed with that kind of diagram, like this one. Another one from 1968, which comes from a fairly well-known paper by Melvin Conway. And he was using this. We found these ideas all over the 60s. People are drawing like, networks, that's the word. We actually see an uptick in the usage of that language. But the system I was working on, so we had network for TCP/IP network. We had network as a data structure, a generalized data structure, so following the maths tradition. But the system I was working in the power industry. This is electricity. We also had another, it was when I looked at the code and thought, wait a minute, we've got we actually had 4 or 5 different things called network, but these are the 3 that I specifically remember. Because of course there's the electricity network. System of cables for the distribution of electricity to consumers. This dates back to the late 19th century. Okay, interconnected electrical conductors or components, sometimes including a source of electromotive force that provides more than one path of the current between any 2 points. So this is a sign on a substation, danger of death. But this is, you get your electricity and you get stuff like this, which is quite useful. You can power stuff. And we talk about that. So we had multiple forms of the word network. Now, at the time, one of my colleagues was thinking of this as just being a name-spacing problem. Whereas I was sitting there going like, yeah, but none of these are actually a network. Because what is a network? If we go back to the 16th century, I did promise the 16th century earlier, work in which threads, wires, or similar materials are arranged in the fashion of a net. Well, in other words, it's to do with fishing. It literally is to do with fish. And so that's what informs all of that. So network itself is not so much a metaphor, but more of a simile, but it is metaphorically inspired. It's by analogy. Oh, like a net. And we've ended up with this whole vocabulary, much of which has gone way, way beyond what will qualify as a metaphor. So I'm going to end with a couple of points here. To be good, considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. Another quality of a good metaphor is that it should not have too many obvious points of conflict. It will never be perfect. And the third, familiarity to its audience. So we can look at just one last system here. So welcome to Brexit Britain. This is our new technology program. It's a legacy system. We're not entirely sure what it does, but it seems to work twice a year. We don't know what the original motive of the developers was. We don't know who they were. They've since moved on, hopefully to better companies. But we do have the language of legacy. Spaghetti code, which kind of works as kind of a cute description, but then people start coming up with, but it's not a description of something that's bad. I quite like spaghetti. And then people come up with, they try and play with it, and they say, oh, yeah, lasagna code is much better because it's layered. And it's just like, well, you're telling me that that implies lasagna is good, spaghetti is bad. Not in my book. I prefer spaghetti. And then each generation rediscovers ravioli. The latest generation are going, ravioli, microservices. The generation before them, oh, ravioli, that's components. Oh, actually, no. The generation before them was ravioli as services. And these days we have microservices, which are actually larger than the services were, but maybe we've messed up the word micro as well. And then we had components, and then we had objects. Each generation rediscovers this. And then we have things like code rot, software decay. These are natural processes, but the problem is they don't have the right entailment because if I leave my code alone for a while, it doesn't rot or decay. The ones don't decay down to zeros or 0.5 or anything like that. They're just as they were. So the problem is that it lacks agency. Entropy, I always thought, was a really good description, measure of disorder. The problem is it turns out that unless you've got good knowledge of physics, then this is not a good metaphor, because then I have to explain what entropy is. So I'm going to explain something abstract in terms of something else you don't know. No. The same applies to technical debt. We'll get back to unhedged call option. If you're in fintech, this makes sense. If you're outside fintech, doesn't help. Housework, that's quite a good one. So, we can actually see that there's a number of different points here that we can kind of walk away from. But when we look at this stuff, there is an explicit recognition of metaphor. Martin Fowler helped popularize this idea, although Ward came up with it about a decade before. Technical debt is a wonderful metaphor developed by Ward Cunningham. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to financial debt. The problem is that Martin used the term, he used it extensively, quick and dirty. That has a negative association. So in people's minds, they started going around going, yeah, it's all bad. Yeah? So we end up with this kind of idea but that's not what the original plan was. Ward wanted us to reason about our code. He was talking about, he said, the whole point of the debt metaphor, back in '92, shipping first-time code is like going into debt. A little debt speeds development so long as it's paid back promptly with a rewrite. Notice he's describing borrowing. It's not debt, it's borrowing. But we focused on the wrong detail. He said, obviously, don't be an idiot. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. And I'm going to skip that slide. So technical debt, the issue with technical debt is when people say, oh, we have a technical debt problem, I kind of, well, Kevlin, we have technical debt. Is that a bad thing? They kind of look at me like I'm an idiot. I could well be an idiot. But the problem is they haven't said what their problem is. They have an unmanaged technical debt problem. If you have technical debt, that's not necessarily of itself a bad thing. So there is an idea here that we often confuse these things. We confuse this notion, and we get a little bit closer to it with the housework metaphor. My theory of tech debt is housework is the correct metaphor for the thing we call tech debt. But we can't use it because tech has been made up of people who don't do housework or manage housework being done. And what we actually see is that there is a confusion. People often say, yeah, they're focusing on cause, but tech debt is not a cause of a problem. Tech debt is an effect, or to be precise, unmanaged tech debt. So when people say we have a technical debt problem, most of the time they actually mean they have a technical neglect problem. That is a more accurate metaphor. It's not that they don't have technical debt, but the problem they have is there. We actually see this, we actually go back to Meyer Lehman. He talks about it. As an evolving program is continually changed, its complexity reflecting deteriorating structure increases unless work is done to maintain or reduce it. Notice what he uses. He talks about this as maintenance, but we have ended up using maintenance as a different word. The correct word we end up using maintenance for feature extension and bug fixing, whereas he's actually talking about maintenance in the sense that it's actually most like the real world form. And maintenance is an action. What we're trying to do is identify inaction, for which we have a word. And that word is, back to this, neglect. So, in that sense, we can actually see that there's a whole kind of system of possibilities that we see in this. So in closing, although a metaphor may successfully capture a part or some aspect, coverage of most concepts is improved by explaining them through multiple metaphors. The idea, working with mixed metaphors is the norm rather than the exception. We should remember that we're already abstracting when we do this, so we're not going to end up with a perfect metaphor mapping, and sometimes forcing it is going to be difficult. But we should also remember that we are a couple of levels removed, so I will leave you with a useful word, pataphor. An unusually extended metaphor where a figurative expression or contrast is made against a metaphor rather than against a reality. In this sense, we can say a pataphor is 2 levels removed from the reality being described, which is a little bit closer to what Lehman was describing. And we should be comfortable with that level of indirection, but we should also be aware of it and understand that sometimes we want a little bit of the looseness that comes with that, but sometimes we need to push back against it. But it always has consequences in terms of meaning and how we think. Thank you very much.